So in this target, we are going to be using the Pythagorean theorem to solve problems with right triangles. And what's good about this is we've already done recently Pythagorean theorem when we talked about distance, and then we've also already done work with right triangles. So a lot of this first part, especially the first couple things we write down, is going to be review, but I think it's worthwhile to write it. So down in this section to the left, let's go ahead and write down the words Pythagorean theorem. Okay, Pythagorean theorem. Now again, I know we literally just did this recently, so it should be fresh, but just as a reminder, remember that's a squared plus b squared is equal to c squared. Now one of these letters is super important, and that's the letter C. So remember, C always has to be the hypotenuse. Okay, C is always the hypotenuse. Remember that the hypotenuse is the longest side and is opposite of the right angle. Okay, so the hypotenuse is the longest side that's opposite of the right angle. So down here on the right, if we think about this, here would be my right angle, that 90 degrees. I would draw an arrow going across, and here is side C. So that arrow is always going to point to side C, the hypotenuse. And again, these are things we've talked about, but I just want to make sure we're clear. And then A and B, our other two letters, remember those are legs of the triangle, and they're interchangeable. They're interchangeable. So it doesn't matter if we had A here, and B is the base, or we could switch that and have B as the height and A is the base. Okay, those things don't matter. The one that is super, super important though, of course, is side C. We need that one. Now, I want you to make like a little box here just to separate this out, so all of that kind of goes together. But one other name that we need to know or be familiar with is Pythagorean triple. Pythagorean triple. Okay. So a Pythagorean triple is when all three sides, so all three sides of the triangle are whole numbers. All three sides are whole numbers. Now, when you think about how we've used Pythagorean theorem recently, it's a lot of distances, especially on a coordinate plane, and we had a lot of decimals with that. So we rounded those. If we get a decimal answer, that's not a Pythagorean triple. If we get a whole number answer for whatever we're solving for, and the other two sides are whole numbers, that makes it a Pythagorean triple. In the back of our classroom, Mr. Creston has a black frame with white paper on it that lists all the Pythagorean triples. So if you're interested, you want to nerd out for a second, some point before class or after, you could check out all the Pythagorean triples, which I'm sure you would be interested in. So that's the thing we want to remember, though, is that it's all three sides being whole numbers. Now, there's also one other rule that'll be helpful for us, and that rule is what we call the 3, 4, 5 rule. And this rule shows up a lot. I know when I've talked to other teachers who do a lot of ACT prep, a lot of the Pythagorean theorem questions on the ACT follow this rule, which makes it faster to solve the answer. So if we can remember this rule, it'll really help us when it gets test time. And here's what this rule says. If we have a right triangle that has 3, 4, and 5, or has multiples of 3, 4, and 5, we can put those together really fast. And so here's what I mean by that. If we have a Pythagorean or a right triangle where the height is 4 and the base is 3, and they ask you to find C, well, we know that 3 and 4 and the next side has to be 5. So it's the 3, 4, 5 rule. So that makes it way faster to solve instead of just doing 3 squared plus 4 squared equals C squared and working all that out. Okay. If we try this again, so let's say I know C this time is like 15 and the base is 9 and they want me to figure out the height. We'll say that's A. So let's think about this. 15 is the same as 5 times 3. 9 is the same as 3 times 3. And so we want 4 times 3 is going to be this side. Well, 4 times 3 is 12. So we know that A would equal 12. So we can follow that 3, 4, 4, 5 pattern. And again, you're not going to always have this, but it is something that can be super helpful. And obviously, since these all give us whole number answers, this would be an example of Pythagorean triple. Let's try one more. Let's say I know the height is 28 and the hypotenuse is 35, and this time they want to know b. Well, I can say, okay, 28, does that follow the 3, 4, 5 rule? Well, that would be the same as 4 times 7. Okay, let's go to 35. That's the same as 5 times 7. Okay, and so b would have to be the 3 times 7, because we want 3, 4, and 5. 3 times 7 is 21, so b equals 21. Okay, so again, this won't be every example. Obviously, we've done lots of Pythagorean theorem this year and different things, and we haven't had a ton of these, but I do know just from ACT prep that they like to throw these in, so if we can catch them, that could be super helpful. Okay, all right, with that as the intro, we're going to look to the next page in our notes. So go ahead and find the next page in your notes. So at the top of the next page, you're really going to do 3 and 4 on your own. I'm just going to quickly remind you, first of all, what the directions say, but also setting this up real quick. So it says find the unknown side length. So these are right triangles. We're going to use Pythagorean theorem. Now this part where it says simplify answers that are radicals, we're going to actually change this slightly, and we're going to say write answers as decimals. And we're going to round to the tenths place. So 1 decimal place, the tenths place. Okay, and then it says, tell whether the side lengths form a Pythagorean triple. Remember, Pythagorean triple is all whole numbers. All sides have whole numbers. That's what we're asking. Okay, so I'm going to remind you just a little bit on 3, then you're going to do 3 and 4, and then we'll talk through 12 just a smidge. So on 3, remember that opposite of my right angle is always side C. So that tells me side C is missing. Okay, so I'd have A or B. Remember, these are interchangeable. And I'm going to set that up into A squared plus B squared equals C squared and solve that. Same thing over here. Find where C is, set up A squared B squared equals C squared, and work that through. So I want you to do 3 and 4. So we're going to pause the video, do 3 and 4, and then we're going to kind of talk a little bit on 12 before we move on. Okay, so do 3 and 4 right now. You can work with your shoulder partner. All right, guys, so let's look through these real fast. On the first one, number 3, it's pretty straightforward with A and B given. You work those out with 4 plus 1 is 5. Remember, the inverse of squaring a number is square root. So we square root 5 and get approximately 2 and 2/10. So 2 and 2/10 is a what is equal to C. Now, it's approximate because, remember, this is a decimal that we rounded to the tens place. Now, the second part of the question asks, is this a Pythagorean triple? These are not all whole numbers since this was a decimal, so no, this is not a Pythagorean triple. Remember, they have to have all 3. Now, number 4, we'll do it kind of the long way, and then I want to ask you some questions here, ask you if anyone noticed this. So we have C this time is given. It's A that's actually missing on this question. So A would be left filled out, like A stays, and then we work it out from there. Now, when we get to this section right here, 64 has to move over by subtraction. Since it's positive 64, gives us 36. Again, the inverse of squaring is square root, so we square root 36 to get 6 equals A. This is a Pythagorean triple because we had 6 and 8 and 10. Now, one thing I wonder if anybody noticed is if we look at these 3 numbers, change colors here real quick. If we look at these 3 numbers, 10 is 5 times 2. 8 is 4 times 2. So remember the 3, 4, 5 rule, we used 5 and 4. We could have said x was 3 times 2, and that's going to give us 6. So we could have done that a little bit faster. Those are the things I was talking to you about. But if you didn't catch that that was the rule going on, that's okay. But that's how we could have done that one a little bit faster. This one, again, is a Pythagorean triple. All right, so let's move over. I just want to ask a question about this one or make sure we're good here, and then we'll be ready to go. So what they give us is they give us x, 2, and 3. So remember, as we're doing this, when I look at the right triangle, so this part here, I know opposite of the right angle is always side C. So x is going to be our C side. 2, we could have A or B. We'll just use A. We'll make that A. So what we're trying to figure out is what this side, side B, is going to be. Now, the line that goes across, remember, tells us these two sides here and here are equivalent or equal. So if this is 3, that's going to make this side 3 also. So there's B. All right, I'm going to give you a second, pause the video, go ahead and finish up this problem. All right, guys, so as we look through this, we end up with the square root of 13, which is approximately 3 6/10. This is not a Pythagorean triple because they're not all whole numbers. So this one is not. So then as we go and look at 15, I'm going to give you one thing to remember and then let you work. So remember, like what we saw in the last problem, that these lines mean that all those sides are equivalent. So if I know one of those side lengths, I know all of those side lengths. So what I want you to do is go ahead and get those side lengths based on what we know here, then see if from there you can figure out x. So we can pause the video again, and you guys work that out, see if we can get x. All right, guys, so as we come back in this, remember we had 14 as the number they gave us. All of these dashes are equivalent. That makes all of those 14. I can go into where my right angle is, draw my arrow over. That always is going to point to side C. So that makes A and B to be 14. C is what's missing. So I can set up what you see down below. I get down to here, and it's 196 plus 196 equals C squared. I ultimately end up with square rooting 392, forgive me. And then that gives me with approximately 19 8/10, which means if I have two whole numbers, that's great, but I need all three, so this is not a Pythagorean triple. So then our last question on this page, before our more box, is number 17. Now I want to make sure we look at a few things here. First of all, we want to remember that if this side is 90 degrees and it forms a straight line, and we know this, that means this is 90 degrees. Okay. Now, what we don't know for sure, what we can't prove, is that that top is truly 90 degrees. A lot of the problems we've done have this marked. This one doesn't. So we're not going to be able to assume it's 90 degrees and just use what's around the outside to solve for x. Instead, we're going to have to go off what we know to be true, which is this information here. So remember, as we do these problems, we start at the 90 degree and draw that arrow out. And that's really important. That's going to tell us what C is. So we're going to do this in both directions so we can see, okay, these are going to be C in these triangles. So when you think about the triangles we have, we've got this triangle here, okay? And then we also have the medium triangle on this side, which by now we should be really good at identifying these, I'm sure. Okay, so it looks like that. Now, to find a third side when it's missing, like x is missing, we need at least two other measurements. So when we look at these triangles, what we do know is this pink triangle does give us two measurements. In fact, they give us enough to figure out what this other side is. So remember, if 10 is equal to C, that can make 6A or B, it doesn't matter. I'm going to put B there, and that means A is the missing side that we need to find. Okay, so I want you to pause the video and go ahead and find what side A is in this problem. All right, guys, we're going to check how this went. As you notice, I don't have any work shown, and here's why. If you notice this, which hopefully somebody caught this, 10 is equal to 5 times 2. 6 is equal to 3 times 2. So we can use that 3, 4, 5 rule and say A is equal to 4 times 2. And what does that make A? That makes A 8. So I know now that that length is A. Well, if I know that length is 8, I can go ahead, subtract these two, and get my value on this side. Okay, so my A on this triangle is the same as 12 minus 8, which is going to give me 4. So now if I look at the yellow triangle, I have a number for A and a number for B, and I can work to find C. So I'm going to pause the video here and go ahead and let you guys figure out what C is. All right, guys, let's check how we did. So 4 was our A, 6 was B, square those to get 16 and 36, add it up to get 52. At this point, we need to square root 52, which is a decimal, so that's an approximate, and we round that, that's approximately 7 2/10. Now remember, the question does ask, is it a Pythagorean triple or not? Since one of the values is a decimal, we would say this is not a Pythagorean triple. Okay. All right. So I'm going to put some questions now in the more box, and that'll be the next section as you guys are going to go ahead and do these. You will obviously need your book for these questions. So there's 5 that you're going to work on. You can work on them with a shoulder partner. You can ask Mr. Armstrong for help. You can ask a fellow student for help if you're stuck. But what we'll do is I'll write the questions in here, the numbers like normal, and then we'll pause the video. You unpause the video when you guys are done. We'll check our answers and go from there. Okay, and then there's one other section we need to get through. So with that, the numbers you're going to do are on page 538. So there's the first row is going to be page 538. You're going to do number 7, number 8, and number 14. Okay. When you get down to the bottom row on page 539, you're going to do number 18. And then you're going to finish up with number 13. Okay? So here's the 5 questions going in your more box. You can go ahead and pause the video, and then when everybody's done or you're ready to move on, we'll unpause it and check our answers. All right, guys, so here are the answers to the more box. Go ahead and pause the video if you could, Mr. Armstrong, and you guys can just read through these together, check them together. Number 14, just kind of be aware. Remember, when we have the same markings, like 2 lines or just 1 line, those tell us that those are congruent. So the X can go for both of them, 20 goes for both sides, and then we can use what's shaded in pink to find our answer. So go ahead and pause it. You can look through these, and when you're ready, unpause it, and we'll move to the next part of our notes. It's just part of the question because this blank we're going to fill in is finding the area of right triangles. Now remember, if we had a rectangle or a square, the area we would say is base times height, right? Base and height. So remember, and we did talk about this recently, that the area of a triangle is just a rectangle split in half. Okay, remember that part. So then the formula for the area of a right triangle is either, you could do it either way, base times height divided by 2, because we're cutting that in half, or we could say 1/2, because it's half the square, times the base times the height. Either one of those will get us what we want. We're still going to round to the tens place. We're still going to round to the tens place, okay? So let's do, we're just going to start question 25, but then you're going to do, finish 25, do example 3. We're going to work through number 29 together. So let's just start then on these first 2. I'm going to zoom in just a smidge here. Okay, so these are the 2 we're going to look at. And again, I'm only going to get you started on this. So first things first is, remember, go from the corner, draw your arrow up. We know this is side C. And remember, what we need is the base and the height measurement in order to figure out area. So if this is C, we could say 9 is A, and 9 is like the base. Okay, 9 is the base. That's A. So then what's missing is part that we need, which is the height. That's going to be B. So remember, in all of these, in order to find area, we have to know the base and the height measurement. Okay, so first thing you're going to do here, once you pause this, is find B. So you're going to find that height, use the Pythagorean theorem. Then the second thing you'll do is use the base and height to find area. Okay, base and height to find area. Now, once you finish this, I want you to take what we've done before and in this problem, come over to example 3, and see if with your shoulder partner you can figure out how to find the area of this bigger triangle with what they give you, okay? So pause the video, see if you can do these 2, and then I'll put the answers up so that when you unpause the video, you can see what the answers are, and we'll go on to 29 together. All right, guys, so let's look at number 25. So we started with we need to find B, use the base and height to find the area. B should have been 7 9/10. You can see that equation there. And then we should have gotten 35 6/10. Now, the label is important. Since we're finding area, it's always something squared. So it's centimeters squared. Remember, area is the inside of our figure. So when we find that, that's squared. Okay, now as we look over at example 3, obviously the answer isn't here because I want to make sure we understand where they get things from. You guys were trying to find h here and then use what you know from that then to be able to find the area. Well, one thing we can say about triangles is if these two sides are the same, basically what this means is this line in the middle becomes a bisector. Bisects it. Okay, so that means it splits this 10 into 2 equal parts, which means that would be 5 and 5. Then from here, we can take what we know to solve for the height, and then we would use our base and our height. So remember, we take our arrow, we draw it out. This is always side C. That means this could be A, and H is like B. So we'd have 5 squared plus H squared equals 7 squared. So then from here, you would get 25 plus H squared equals 49. We got to move this over by subtracting 25. So we'd have H squared equals 24. And then when we end up square rooting 24, we get approximately 4 and 9/10. So what that means back up here is that H, the height, is, we're going to say 4 and 9/10. So remember, I know the base of this triangle is 10. Okay, I know the height is 4 and 9/10. I'm going to multiply those together and divide by 2. So I'd have 4 and 9/10 times 10 divided by 2, which gives us a final answer of 24 and 5/10 meters squared as the area for that triangle. Okay, so I'm going to try and get us started on 29. There's a few things that are a little different, and then let you guys work through it, and then we'll move on to the more box. So as we look at this question, this figure, what you might notice is this looks like a rectangle within you've got a triangle here. Okay, that's partitioned off. So really we've got two figures here and here. Now, since we know that this is a rectangle, we would say, okay, this is 90 and this is 90, which also means that this side is 90. So we've got all these 90-degree angles to work with. So the first thing we want to figure out is it possible to see what just this smaller piece of the triangle is? Is it possible to figure that out? So real quick, take like 30 seconds, pause it. How might we go about figuring out what that part of the triangle is? So hopefully you figure this out. We can figure this piece by saying we know the entire shape is 16, and just this part here is 10. So I could subtract 16 minus 10, which is 6, and then I know that this part of the triangle, the base of the smaller triangle, the small piece, is 6. Okay, so now we've got this. Now we're going to use that then to figure out what our height is. So we're trying to figure out this height. So think about, we have a right triangle that's green. Draw your arrow over, and I want you to use Pythagorean theorem to figure out what the height of the triangle is, which is actually the height of the rectangle as well. So pause the video, go ahead and do that part. Figure out what the height should be. Okay, so hopefully you were able to figure this one out. We had 6 was A, 10 is C, B is what's missing. Work through all of our Pythagorean theorem here. We end up with H being 8. So I'm going to go ahead and I'm going to come up here. I'm going to erase where it has H is the height, and I'm going to put 8 here. Now, if we know that this part, this height of the triangle is 8, we also know that this is 8 over here because it's the same shape stretched across. So then once we get to this point, we're ready to find the area. Now remember, there's two shapes we have to find the area of. We have to find the area of the triangle. We have to also find the area of the rectangle. Okay, so again, we're going to pause this video, and I want you and your partner to work through this and figure out what's the area of the triangle, what's the area of the rectangle, and then what would the total area be? And that'll be our final answer. Okay, we're going to write that down here. So pause the video, do these pieces, and then we'll check our answers here in just 1 second. Okay, so let's see how we did. So the area of the triangle would be 1/2 times 6 times 8, which gives us 24 centimeters squared. The area of the rectangle is 10 times 8, or base times height, which gives us 80 centimeters squared, which means the total area of this composite figure is 104 centimeters squared. more box. So here's our last two. And so you got number 27 and 28 on page 539. Pause the video. Once you guys are finished working, unpause it, and I'll have the answers up here. We can talk through them, and then we'll be all set with our notes. All right, guys, so let's take a look at this one. Obviously, the answer is here, 25 and 2/10 centimeters squared, but let's talk about how we got that. Again, similar to the other question we had earlier, if both of my sides of my triangle are the same amount, that means that these are basically bisected. They're split in half. So half of 7 centimeters is 3.5 and 3.5. I can use that then to solve for the height, which would be b. So when I do that, I get a height of 7 and 2/10, so I'd use Pythagorean theorem there to get that. Plug that into the area formula, and I end up with 25 and 2/10 centimeters squared. If we come over to this one, okay, this one was a little bit more complicated. They gave you the height was 4, but now you are missing the bases. We had to figure those out. So remember, we start with our 90 degree and draw that out, and draw that out. On our triangle on the left, that means we had C and B, and if we remember the 3, 4, 5 rule, we could have got 3 pretty quickly, otherwise we'd have to do Pythagorean theorem to get that. Over here, we had Pythagorean theorem that we had to work out, so we had 4 squared plus A squared that was missing equals C squared. When we work that out, we get 7 and 5/10. That means the whole base here is 10 and 5/10. So then when we go over to find the area, we'd have the base of 10 and 5/10 times the height of 4, and you could either multiply that by half or divide by 2, and we get 21 meters squared for our area. Now, as we wrap up our notes, I know this has been a lot to do and a lot of work and writing for one class period. So if there's any time left in class right now, you can use this to work on spiral math. You can use this then to work on something from another class. I really don't want you just sitting and talking unless there's like no time left of class. That would be okay. But ultimately, rather than giving you more Pythagorean theorem to do today, we're going to hold that off till I see you guys again on Friday. But what you can do right now is work on something else, specifically spiral math, if that's not done. Okay, so thanks for, I know this was a lot of work, so thank you for just going through the video, getting all of this done, and we'll be all set for Friday, okay? All right, have a good rest of the day, guys.